all. Let's start with our today's decision with this amazing DSA visualizer. Use this link to get a 7-day free trial. Let's start with our today's question, and today is add two numbers. Two non-negative numbers are sorted as linked list of in reverse order. Add them and return the sum of the linked list also in reverse order. Okay, you can see all of the tags here. So let's take this example 243564. Okay, so this is our question. Add two numbers 2 4 3 5 6 4. Okay, these two are the two numbers, but these two numbers are reverse and we have to sum them up, and also the answer should be in reverse order. What does it means? It simply it simply means that these two are numbers, and the actual numbers are 3 4 2 4 6 5. I just reverse this. Now sum this up. 5 2 7 6 4 10. Our carry is 1. 3 4 7. Carry 1 8. Okay, so this is our answer, but that answer would become 708. So sum from the just the opposite, okay, just the opposite one. So if you go to the last step, see the answer 708. Okay, our answer. But now the question is, how could we do this? Okay, we are given a linked list. Okay, so let's dive into the solution. Let's first think how we actually solve it. In this way, in this summation, in this summation. How we solve it? First we go and add these two numbers. Okay, let's take another example. Okay, yes, now first we add these two, like this 2 and this 5, and got 7. Okay, then for 10 we put the 0, which is the last index. Okay, here, and this one become a carry, this one become a carry. Okay, let's suppose this is a n, so in percent I, or rather in percent 10, so 10% 10, what of tongue twisted. So if it's n, so n percent 10, n is 10, 10%. Modular division, the 0 is here. See this, the 0 is here. Also n by 10. Okay, now the value of n is 10, so it become 10 by 10. It is 1. And what is our carry? So this refer to the value which you want to insert into this sum, and this refer to the carry, this refer carry which we actually need here. Okay, and go to the next step. We just add this to 3 and 4, got 7 for that reason, and then we add this carry here and got this 8 here. We perform sum of two numbers like that. It is the way. So we add them, we take at most right side value, and then the remaining part will be carry. Okay, this we go from left to right every digit. So here in this question, so let's take this 2. Okay, this is our let's remove it. So this is our actual list. So see here, See here, actually see here. 2 and 5, 7. 6 and 4, 10. 0 come, 1 goes carry. 3, 4 and 1, 8. We got our answer. So our approach is nothing but we just, so this is our question. So our approach is nothing but we start from the start towards end. For every time we add the corresponding value, and every time when we go to the next element of the linked list, we do it in both linked list, not in a single linked list. With both linked list, we just come to first step, we just come to first step, add these two. Okay, if we got a carry, we do it, or we add a 0, then we go and to the next element, next two element, and then we add it. We go to the next two element and we add it, and also we update our carry, and also every time we add our carry into this. Okay, this is just a summation like how we perform sum, but here we every time we traverse the both list at a time, not just like that we do another list. We go to one list, we go towards in, and one list we go not towards not uh, going forward. We only have this if we have like another number, then we have no number here, we just have to calculate it with a carry. So this is a case where we have to, otherwise we have to traverse the list every time. Okay, so now see this. Each list hold the digit of number in a reverse order. So index 0 is one place. Add them exactly like grade school addition. Okay. Work summing one column at a time and carrying the overflow. Carrying the overflow is means the carry we actually do. It is just the summation, but with linked list. So these two are list. See, first is 2, first pointer at 2, another pointer at 5. Both are in the first position. Then we just add them up. We got a 7. Okay, we put it. Then we simply go to next time. See, we traverse both pointers at a time. Okay, we got this. We got 0. We got 0 because we got 10. And we have to calculate the sum digit, what do we want, and also the carry. The digit is 0, the carry is 1. Okay, and we go to next step, 3 and 4 7, and we add the carry here, which is now become 8, and we got our answer. Okay, so now let's write the pseudocode. Okay, we are given, let's suppose, two node with two pointer p1 and p2, because here actually here you using pointers p1 and p2. Let's take p1 and p2. So take a function, or taking a function, we just directly put it p1. Let's put it directly. I think this should work fine. So just take a dummy node, which is nothing but a node, and also a tail. This dummy node and tail is nothing but just the uh, pointing of this result, point of this result, the head of this result. Okay, the tail traverses the whole result, and the head is dummy next, as usual, like previous questions. So we tail point to dummy. Okay, okay, not a dummy. Now we are pointers p1 and p2, and we have to take a carry. So our carry is at the starting is 0, because every time the carry will become 0. Tail, the list p1 is not pointing to any null, or or why or here, because we have to traverse it, that if any list pointing to the next list and also add with our carry. So for that reason we have to do it every time. So p2 not equal to on 2, p2 not equal to null, or we have a carry. Why I do this? This is simple elementary math. Suppose I think yes, we have things here. Just remove this. Okay, so these two are now linked list. Now add it. Okay, add it. 2 plus 5 is nothing but 7. 6 plus 4 is nothing but 10. Okay, so we put 0 here, and now we have carry 1 here. So how could we put the carry? We have a carry, but if we don't add it to our sum, the sum will not work, so we have to add it here. So just see it na, 42 and 65, simple. 6 is 2 and 5 7, 6 and 4 10. But I just put directly 10 here, but we actually, the rule says not 10. The first we put 0 here, and the carry is 1, and now the carry added to it. So this is our answer. So for this carry or this carry to be stored, we have to ensure that there is no carry left. We initialize carry with 0. Okay, so every time we update our carry using this formula which is saw it here, these two. Okay, these two are the formula of, okay, formula for carry and the value or the digit, anything you want. This is the formula for value, this is the formula for carry. Okay, now if the P1 or for every digit, okay, for every digit we need a sum. At the sum store, the sum store this value. So when we are in 5 or 2, the sum value is this is nothing but our sum s, let's suppose s. So initialize with it 0. If p1 not equal to null, okay, it simply means the value at the p1 possible. So we just add sum plus equal to p value. Okay, now similarly for the second list, if p2 not null, then sum plus equal to p2 value. Okay, so what do we actually do it here? So we added the values into the sum. Okay, okay, now also if we have a carry, so we have to add it. So sum plus equal to become carry. Okay, we add our carry here. Now from this case 4 and 6, we let's suppose, okay, let's suppose 4 and 6, our carry at the starting is 0. We got our sum become 10. Okay, but you cannot put 10 here. So we have to calculate the carry, digit, the digit and the carry, the digit and the carry of this number. And how could we do this? Every time for every digit, every number, not digit, every number, we can, using this formula we can easily calculate the value and the carry or digit and the carry. Okay, so first calculate the carry. So what is the carry? So carry is nothing but some percent 10. Okay, so n is nothing but sum here. Okay, so some percent 10 will become carry. Now we need to create, okay, now we need a value. Now we need a value. Okay, we need a value. And what is the value? Value is simply, value is nothing but the digit which is n% 10. So for that case, simply do one thing, and we also create a node for this value, so we can easily write create node value equal to, and what is our value? Simple, sum, I made a mistake, it should be this, not percent, sum percent 10. This is our value, that is our carry. Okay, we just create a node using this value and add the node after the tail. So tail, tail next add the value node. Okay, this is our formula, and at the end just return dummy text. Yes, we do it in optimal time and space complexity. So our code is simple. Our code. Yes, I think it would be much better to read in this white environment. This is our code. Now let's go to the question and properly code it out. First, we simply need a dummy. I don't need this. Okay, so first we simply need a dummy, which is nothing but a node. Next, we need a tail, which is nothing but pointing to dummy. And carry 0 at the starting. Now, while list 1 not equal to null, or list 2 not equal to null, or the carry. It simply means that either of the list is present or there is a carry present. Okay, this loop only works while either of the list are present or the carry is present. Okay, so now take a sum, which is nothing but starting with 0. Now we have to add it. If a1 not equal to null, then simply add it to sum plus equal to a1 value. Okay, so you just simply copy it. It is L2 and this should become L2. Okay, so we got our values, but we also have to increase the L1 and L2. So for that we need a loop. Should be both of the cases. Control Z. Is now pointing to the next portion. Similarly here, yes, so this is our solution. So the list one is now pointing towards the next element. Okay, in pseudocode we don't need to mention that, but here we have to explicitly mention that. Okay, now if any carry present, add it to the sum. Now calculate the new carry. Carry is nothing but sum by uh, by 10. Now create a node with the value. So first we have to create a node. Okay, but first let's create a node. Let's create a node, new node, which is nothing but new. list node, and now we have to specify the value, okay, which is nothing but sum %10. Calculate the value here, then we create a node with that value. So now put this new node to the tail, okay. So tail next, pointing to this new node, and increase our tail to the next, tail equal to tail next, as simple as that. So now create a head, because we have to return the head, which is pointing to dummy next, pointing to the next of dummy. Then simply delete. I uses this delete command because I actually using C++, and C++ we don't have inbuilt garbage collector, so you have to delete the node also, which is dummy, and at the end just return tail, okay. So just run it and check it if we, okay, we have a wrong answers. The output is, oh, I return tail. The output is the head. It's working. Let's submit it. It's submitted. So the time complexity is maximum of the both of the length. What is the maximum of both of the length? Because it traverses the whole list. Also, the space complexity of this new node, or actually store the result into a new portion or new thing, which is dummy, and then compare it with head. Then just put head in the beginning. So the time space complexity is also big of m or n, which is maximum, this one, and n and m are the length of the tool list, okay. So this is our question at two numbers, okay. Go solve this question, use this platform, and if you go to this platform, use this link to get a 7-day free trial, okay. Check out this platform. Thank you very much.